try that. Go ahead if you can verbalize it. I'm ready. Hold on, not quite ready to write it. I thought I was, but I'm not. Okay, now I am. Okay. First of all, when you are adding, subtracting complex numbers, you add the complex part and you add the real part. Okay? That's the complex part. That's the real part. So let's do the complex part first. What is 3i minus 5i? And now let's do the real part first. What is minus 2 minus a minus 7? Correct, plus 5. So that is the correct answer. It's not quite in the right format. In other words, when we talk about complex numbers, we want it in this format, a plus bi, okay? So, yeah, let's just switch. It's 5 minus 2i. And in fact, I would rewrite, even before, I would probably do it like that. In other words, I would put the real part first, and then the imaginary part, and then I immediately come up with 5 minus 2i. Okay. What else? Now, is your screen size big enough to see everything that I'm right? Okay, all right. I kind of thought it might work on your end. I don't think it would work on my end because I wouldn't be able to write in that small of a screen area. But I'm writing in the regular screen area on my end, so it's not hurting me at all. But yeah. I tell you what. Let me go down and get my speakers, so I don't have to hold my phone up to my ear. Yeah, 1 second. It's hard to write and hold the phone up to the ear at the same time. So, I got it. Give me 1 second. I'll be with you. Hold on. All right. Can you hear me? Okay. There. Go ahead if you can read another one for me. Okay. All right. Where we want to start here is with that radical. Okay. In other words, what does the square root of 80 turn into? Now, the job here is to find a factor of 80 that is a perfect square number. Well, your perfect square numbers are 4, 9, 16, 25. And you would prefer the largest one. In other words, 4 is definitely a factor of 80, but so is 16. In other words, can I not write that as 16 times 5? And square root of 16 is 4. So square root of 80 is actually 4 square roots of 5. So let me go back up here and erase square root of 80 and write 4 square roots of 5. Now you'll notice that I can do a lot with that. I can simplify it. How do I simplify that expression down some? Not by 8, but by 4. In other words, what I'm looking to do is to divide the top and the bottom by the largest number I can divide both by. Well, that's 4, not 8. I can divide 20 by 4, I can divide 4 by 4, and I can divide 8 by 4, okay? But I could not divide each one by 8. But I can divide top and bottom by 4. So if I divide top and bottom by 4, that's what the minus 20 becomes. The 4 becomes 1, so it's just that. And then on the bottom, I'm dividing by 4, so it becomes that. So that answer is as simple as you could make it, except for one other possibility. You could say that that's the same as minus 5 over 2 plus or minus 1/2 root 5. That's another possible way to express it. Now, I'm not sure that this is necessarily the second way is the correct way. You'll never lose points for that. If you end up with a complex number, in other words, if I had an I like that, then this second way is the standard format for complex numbers, where you write the complex numbers second, not first. Okay? So depending on if you have complex answers or not, it can change the way you're supposed to write that format. What else you got? Square root of 63? Okay. And again, always start with that. Because if you can simplify that, then we can simplify everything. But you've got to be able to simplify that. So think of, are there any perfect square numbers that divide into 63? There's 4. Check 4. 3 is an odd number. 4 is never going to divide into something that ends in an odd number. Okay, so 63 is not divisible by 4. The next one to check would be 9. Is it divisible by 9? Yeah. it's the square root of 9 times square root of 7, right? Which is 3 square roots of 7. So now I'm going to write it like this. 3 plus or minus 3 square root of 7 divided by 6. Now notice that I can do more with. Reduce that. What do you get? First of all, how are you going to reduce it? What are you going to do? You're going to divide top and bottom by what? Okay, so what do you get? Perfect. There's your answer. Okay. 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 Uh-huh. Okay. All right. When you're dealing with parabolic motion, which is the case whenever you're on planet Earth, and you throw a ball either straight up or you throw it at an angle, and the equation is always minus 16t squared plus the initial velocity, which is 24.5 times t, plus the initial height, which is 2. So this is the height of the ball at any point in time. And if you want to check it, plug in 0 for t. Notice that if you... Go ahead. That is the standard gravitational constant when you're on planet Earth. In other words, gravity is 32 feet or... this is meters. Let me go back, change everything. When you are in meters, it is 9.8. In fact, it might be half of that. I think it is half of that. I think that this is a minus point or 4.9. There's your standard equation. Now, let me explain that just a little bit. If you are dealing in feet per second, then it's always this. Where v sub 0 is your initial velocity and h sub 0 is your initial height. If you are dealing in meters per second, then it's always this. In other words, the only difference is that constant is different. Well, you want your velocity to be in the same thing. If it looks to me like your velocity is in meters per second and your height is in meters, so you don't want to put in a miles per minute there. That's completely different units. Okay? So if you want to know what your height is at any moment in time, let's use the second equation. The only thing I'm not completely sure of is that might be 9.8. Do you know whether it's 9.8 or 4.9? If you have an example that uses meters, it will tell you whether it's 4.9 or 9.8. Almost certain it's, well, if it's in feet, then it's going to be 16. But the problem you gave me looks like meters per second. Okay. Well, it does change the equation. In other words, it changes that coefficient on the t-squared. So I'm going to assume that it's 4.9. And we'll do the whole problem based on that. Okay? And if it happens to be 9.8, you'll know how to do it correctly. So, notice that when time is 0, the h sub 0 has to be 2. And v sub 0 they're giving you is 24.5. So what really is the equation is this. It's minus 4.9 t squared plus, because you're throwing the ball upwards, not downwards, starting at that height. So this is the equation of the parabolic motion of the ball that you are throwing. Okay? Now, let's just look at that for a moment. If you threw it for 1 second, what would its height be? Well, it'd be a little bit higher than 2 meters, right? Because you're throwing it at 24.5 meters per second straight up. So if I plug in 1 for t, I'm going to end up with a height of about 26 almost. 25.6. And that's correct. In other words, here's what's happening. You're over here. You're throwing the ball straight up. And it's going to go up and then down. Right? And the height that it starts from is 2 feet. That dimension is 2 feet. Or, excuse me, 2 meters. And it actually does not matter if you throw it up and down or whether you actually throw it like you would throw a normal ball. Like that. In other words, if I throw it with a parabola motion, like on the right side, then that's still 2 feet off the ground. You're still throwing it up at 24 meters per second. Sorry, I keep saying feet, but I meant 2 meters. And then it's coming back down. So parabolic motion does not matter whether you throw it up or at an angle. In this particular problem, you are throwing it straight up. Okay? At least if I understand it correct. I do notice that there's quite a bit of background noise on this connection. Do you hear all of that background noise? Okay, that's okay. I can work through it. I just wanted to make sure it wasn't a technical problem. So what does it ask you? Besides the equation of the motion, it must ask you, like, what's the height of the ball after 5 seconds or something like that. Okay, what are they? Find the maximum height. Okay. Okay. Okay, at 20 feet? Okay. Okay, the maximum height. We are looking at a parabola, correct? That's a quadratic. Its coefficient is negative, so it's a parabola, opens down. So we need to find that vertex. Do you know how to find the vertex of a parabola? When it's in standard format like this. It's minus b over 2a. So, if we, is that the way you're going to do it? Okay, so tell me what minus b over 2a is. Let's plug everything in. What do we get? Minus what? Minus 24.5. Negative 9.8. You have your calculator? Let me do it on my simple 4-function calculator here. 24.5 divided by 9.8, exactly 2.5. Now, remember that minus b over 2a solves for t. It solves for the horizontal value of the vertex. It does not solve for the vertical value. In other words, we're looking at a parabola that's going to go like this. What they're telling you is that occurs at 2.5 seconds. The question is, what is that? That's the height, right? So how do I get the height? So you take, if I write it properly, it's the same thing as h of 2.5. So that would be negative 4.9 times 2.5 squared plus 24.5 times 2.5 plus 2. Let me try doing that on my calculator. 2.5 times 2.5 times negative 4.9. Hold on a second. Let's see. So what I really want is negative 4.9. I see what's going on. Doesn't like my negative sign. 4.9 times 6.25. That's minus 30.625. And then if I add to that 24.5 times 2.5, that's plus 61.25 plus 2. So the maximum height is, looks to me like 32.6. Hold on, let's see if I did the math right. Yeah, that's 30.6 plus 2. Okay, so the height after 2.5 seconds is 32.6. And that is the maximum height. Because we know that the maximum height is achieved at the vertex. In other words, it's wherever we know that occurs at 2.5 seconds. The question is what is that? And that ends up being 32.6, assuming my math was correct. Okay. Now, when does it hit the ground? At what time? What is its height going to be when it hits the ground? Aha. So h of t has to be 0. So what I'm going to do, in other words, there's two spots where h of t is 0. And that is one right before you throw the ball up. But the other one is when it hits the ground. So the height is 0 when it hits the ground. So what I have to do is solve this equation. Now again, if I have the wrong equation, that is a 9.8 instead of a 4.9, but I think this is correct. Or that is a physics question, not a math question, as to whether it's 4.9 or 9.8. Okay? They really should give you that equation. Did they give it to you anywhere? They shouldn't expect you to memorize that equation, not unless you're a physics student taking physics. In terms of math, that coefficient of the t squared is totally dependent on whether you're dealing in meters per second or feet per second. All right, so in terms of when it hits the ground, got to solve that quadratic. Now, that's not the easiest quadratic to solve that I can see. I would probably have to plug that into the quadratic formula. But you'll get 2 times. In other words, notice that whenever you solve a quadratic, you get 2 answers, right? You're going to get a positive answer, let's say plus 3 seconds, and you're going to get a negative answer, let's say minus half a second. Okay, good. We'll go ahead and do that. But my point is that the reason you get 2 times is, here's the picture that you're actually looking at. In other words, the thing leaves at a height of 2, right? So you're really looking at a ball that's being thrown up and falls down like that. And if you carry this parabola back to there, that's your negative time right there. That's your positive time, 3 seconds. Now, I don't know that 3 seconds is the answer to this quadratic, but the plus and the minus number that you get, the reason you get a minus number is obviously time can never be negative. So when you get your time as a plus and a minus number, use always the plus number. In other words, this is the time that it's going to hit the ground. Now, I don't know that it's 3. If you want to go through the quadratic, we can. Not sure that that's the critical part of this problem to do. Let's go ahead and set it up. Tell me what t is equal to. Once you set it up, we don't need to go through it unless you want me to. But let's make sure you can set it up correctly. In other words, how do I solve that quadratic? What's t equal to? Using the quadratic formula. It's negative b. Right? That's b right there. The quadratic formula starts out with negative b. Plus or minus. Okay. Is it 9.8 or 4.9? Well, I'm not positive. I'm pretty sure that when you are, let me think for a second. Let's see. The speed of gravity is 32 feet per second per second. And that coefficient is half of that. So when you're dealing in feet per second, then this thing is minus 16 t squared. But the speed of gravity in meters per second is 9.8. And that is correct. And so you're dealing with half of that. So the coefficient is definitely 4.9. Okay? So minus 4 times A is minus 4.9 times C is plus 2. Sorry, I ran out of room to write it. Plus 2. All of it's divided by 2A minus 9.8. So, whatever the positive answer of that is the amount of time it takes to hit the ground. Now, you're going to get a positive and a negative answer when you do this all. And I don't think it's terribly helpful for me to do it on my calculator. If you had your calculator, yes, I would say do it. But for me to do it and just give you a number, that doesn't help you much. So, but that's how you set it up. Okay. Now, the last question. When is it at 20 feet high? Well, what am I going to do there? There's your equation. The very top equation is the equation of this motion. Where, yeah, instead of setting h of t equal to 0, set it equal to 20. So then you have this. And just another quadratic to solve. As long as you know how to solve quadratics, you can solve that. And again, you're going to get two answers, most likely. Yeah, you will get two answers, because notice, when you throw the ball up, there's two places. It's at 20 feet right there, and it's also at 20 feet there. So you're actually going to get two answers, one there and one there, when you solve that quadratic. And how would you? No, you plug in 20 for the height, and then you solve that quadratic. In other words, you would subtract 20 from both sides, so you have one side equals 0, and then you use the quadratic formula again. Here, let me be clearer. I have to admit, it really is hard to do this session with all that background noise. So the next time, probably you want to try to find a place that is quiet. And your typical Starbucks is not. The Starbucks where we actually met really is quiet. In other words, there wouldn't be any background noise at all. But I'm going to subtract 20 from both sides. Now I'm going to solve that quadratic using the same quadratic formula. And that's going to tell me the two different places where the ball is at 20 feet. In other words, it's at 20 feet going up, and it's also at 20 feet going down. I don't know if we came up with a maximum H. I don't know if I actually solved all of that, but I think it was like 25 feet or something. But it was greater than 20 feet. So if the maximum height is greater than 20 feet, then it's going to hit the 20-foot mark going up, and it's going to hit it coming back down. And that's going to give you those two solutions you're going to get when you feed those numbers into the quadratic formula. And it's definitely 4.9. And the only reason I'm certain of it is that 32 feet per second is equal to 9.8 meters per second, because a meter is approximately 3 feet. Okay, so if a meter is approximately 3 feet, this is going to be awfully close to 32 feet per second. So I know this is the correct conversion. And I know there's only two formulas. There's this one when you're dealing in meter or feet per second, and there's this one when you're dealing in meters per second. And both of them, the initial velocity is that v sub 0. And both of them, the initial height is that third term. So in your problem, I replace that with 24.5, and I replace that with 2. And that's how I got the original equation. Okay. All right. What else? And like I said, that really didn't matter whether you were throwing the ball straight up and straight down, or whether you're throwing the ball like that, or whether you're throwing the ball like that. All three equations are going to use the same equation. I mean, all three paths are going to use the same equation. It's the equation of projectile motion. The only thing that really matters on that equation is whether you're dealing in feet per second or meters per second. What else you got? Hold on one second here. Let me just check my email and see if I got an email from you that I'd be able to bring it up on the screen. Hold on. I did not ever get that email. Try sending here. Let's try to get that part down, because there's going to be lots of times where you really do need to send that image. So just take a picture of whatever and try sending it to that again, attached as a large image file. It said it just sent. Well, what does that mean, just? 1 second ago or 1 minute ago? Because almost always I get it within 2 seconds after it says file sent, and I didn't get it. I assume it's coming from Brianna Ellis, it'll say. And I don't have an email that I got. And I don't think it went into my junk email. No, I don't see one there either. We should try to solve that problem. Take a picture of your coffee shop that you're in and send it. Okay. Okay. Definitely have to spell it right. And that could be a problem in the future because the next time, in other words, when you type it and spell correctly, the next time you go to type it, it's going to present you with both options. And you're going to have to know which one is correct. So it kind of is problematic if you misspell it the first time. I had this happen before. Somebody spelled it C-O-W-E-N, and then they corrected it to C-O-W-A-N, but every time they brought it up, they got both choices, and they never knew which one to pick. So it's C-O-W-A-N 1949 at gmail.com. Try large. I know large works. I'm pretty sure actual size works also. The only thing I know for sure is that small size does not work. Okay, there it is. I got it. You can see I got it. Ooh, you can see I got it. I see what's going on here. You get disconnected when you send a file. You got to log back in. Yeah, I got your file. Try logging back in. Let me give you the meeting ID number again. Why don't you write it down? It's 973 795 669. And go ahead and log back in, and then this should work. Yeah, I was worried about little bugs like that. I know my son, whenever I'm on a phone conversation with him, it presents problems with him sending files and stuff. Depending on which iPhone you have, that's the best way to do it. Send it before. There you go. Now you're back in, and you can see my screen. Let me pull the first one. Should I pull the first one up or the second one? Let's see. Yeah, this one starts at 1. Okay. The other one you want? Okay. That's fine. That's fine. Okay. And you can see this okay on your screen? Amazing, this technology, isn't it? I mean, it just blows my mind that you can even do this on your phone. Okay, so let's look at 11. Let's draw a picture of 11. Hold on. So they're saying a volleyball player throws a ball 40 feet to another player. That's 40. Okay? Just clearing a net set at 4 feet high. That must be 4 right there. Is that a picture of what they're talking about? Okay. So what they want is the equation of that parabola. Okay. Now, we know that the height of that parabola, this is the time axis. This is the height, h of time axis. And we know, here, let me write it down here in the lower left. We know that h of t is going to be, well, they don't give us the velocity, but they do tell us the starting height is 0. Okay, so this is in feet per second, so this is going to be minus 16 t squared plus the initial velocity she throws it at times t, plus the height, which is 0. So there's our equation right there. Now, what they did not give us was v sub 0. They didn't tell us what velocity she threw it at. but we're going to be able to figure that out, okay? Because we know the vertex comes at 4 feet and it comes halfway between, right? So the vertex must be at 20, 4. Okay? So what that tells me I can do, over here again in the far left, can I write over there? Yeah, good. Okay, so I know that h of 0 equals 0. And I know that h of 20 equals what? What's the height? Remember, h of t is the height. So after 20 seconds, what's the height of the ball? Barely clearing the net. It's 4. So h of 20 is 4. Okay. And guess what? That's going to let me solve for v sub 0. Because if I know that h of 20, up here in the upper right, h of 20 equals 4, well, that means h of 20 equals 4, which equals minus 16 times 4 squared plus v sub 0 times 4. There's only one unknown in that equation, v sub 0. And I can solve for v sub 0. In other words, can you see everything that I'm circling there? Okay. You can see there's only one unknown there, and it's v sub 0. Okay, and in fact, here I can solve that pretty easily. 4 squared is 16. 16 times 16 is 256. So I get 4 equals minus 256 plus v sub 0 times 4. Take the 256 on the other side. You get 252 equals v sub 0 times 4. Divide both sides by 4. You get v sub 0 equals 43. No, 63. Okay, so the equation of this parabolic motion here in the lower right is h of t equals minus 16t squared plus 63t. And you can verify that that is correct by plugging in 20 seconds for t. And if you plug in 20 seconds for t, you will see that the height is 4 feet, which is what it needs to be to clear that 4-foot high net. Now, that velocity is the vertical component of that velocity. And this may be beyond the math that you've taken at this point. I don't know. If I fire something at an angle like that on the left-hand side here, that has a vertical and a horizontal component to it. The vertical component is going to be the cosine of that angle. The horizontal component, no, I got it the opposite. The vertical component is going to be the sine of that angle. The horizontal component is going to be the cosine of that angle. But the net result is that v sub 0 is the vertical velocity. So she didn't throw the volleyball at 63 feet per second. She might have thrown it at 100 feet per second. But the vertical aspect of it was only 63 feet per second. Now, you probably haven't had any of that, have you? Have you had the trig that's involved here? Okay. Well, let's not even talk about that. I don't want to confuse the issue. Okay, but that's how you solve that problem. Okay. Yeah, I don't know why that's the very first problem, but okay, so let's go to 12. Okay, so number 12 tells us the two intercepts. If we were to draw a picture of number 12, we would have the intercepts right there at -3 and right here at 1. And we would be looking at a quadratic. It's got a vertex of -1, -12, which is way down here. With me? So that tells me this thing has to be a quadratic that opens up. There's no way it could open down. Not with that vertex and not with those two x-intercepts. Has to open up. Okay? So, let's start with, let's see, write the equation. Let's kind of start here. Start with vertex format because they've given us the vertex. What can I plug in here? How much of that do I know? I don't know A yet. But I know H and K. Hold on. No, that's the x-intercepts. This is vertex format. When you're in vertex format, the vertex is what we care about for the moment. Well, but what does that translate to? What does -1 translate to in terms of x minus h? X plus 1, exactly. And the -12 is still that. So that's the equation of the motion, but I don't know what A is. However, they have given me another couple of points on the graph. So all I got to do is substitute one of those points into that equation, and I'll be able to measure A. So which point should I use? 1, 0, right? That point right there is 1, 0. So plug that point into this equation, and what do you get? What's y? No. Y is 0. In other words, that known point on the graph is 1, 0. So this function has to go through that point. So I'm going to substitute 0 for y, and I'm going to substitute 1 for x. And now I'm going to solve that, and it's going to tell me what A is. So I've got 0 equal 2A minus 12, 2A equals 12, A equals 6. I've got my equation. Y equals 6 times x plus 1 squared minus 12. There's your answer. I could also have used that point over there, -3, 0. I would have gotten the same answer. But I've got to solve for A. Okay? Now, let's not leave this problem quite yet, because there is another way to do it. And I have become a firm believer that if you want to understand math, You want to understand all of the ways to do a problem. In fact, I read something once that said the difference between the way they teach math in the United States and the way they teach it in Asia, where they do a lot better on their math tests than we do, is in the United States, we have the student do 20 problems in an hour. In Asia, they give the student 5 problems and have them do it each problem 4 different ways. And that is a better method of teaching. So there is another standard format for parabolas, and it's the X-Intercept format, where you have x minus p times x minus q. Have you seen this before? Well, it makes me wonder whether I need to go through it with you. Well, I won't go through all of it, but I just want to make you aware of it because they gave us the two x-intercepts, right? In other words, they tell us that -3 and 1. So I don't have to use the vertex format. I can use the X-intercept format, which gives me this. It's -3 and 1. Yeah, well, that separates it from H and K. In other words, H and K are the vertex, whereas P and Q are the X-intercepts. Okay? Well, that means this equation is also the equation of this parabola, of this quadratic. Okay? And again, I could substitute the vertex for x and k, or excuse me, x and y, and solve for a. And this a is the same a as when you're in vertex format. So we already solved for it, so we know that it's 6. But just to show you that we could do it, I know the vertex is at -12 when x is at -1. Again, if I solve that equation for a, I will get an a of 6. And I can substitute 6 and 6 there, and that's also an equation of that parabola. It's the same equation, believe it or not. It's just written in a little different form. But it's exactly the same equation as we came up with when we wrote it in vertex format. Now, the fact that they give it to you in both, in other words, they gave you both the x-intercepts and the vertex. The reason they give you both points is because you need the other one to solve for a. Whichever format you use, you need to solve for a, and you need another point to plug in. It doesn't work to plug in one of those 2 points to solve for a. It just doesn't. You'll find out that you're dividing by 0. So you always have to use the other point. So whether you use vertex format or x-intercept format does not matter. You would use one of the other points to solve for a. Okay. All right, good. Let's do 13. Write each quadratic in standard, factored, and vertex format. When they say factored, they mean x-intercept. That's the x minus p times x minus q. Okay, so let's take this first one here. What is that in standard format? Exactly. That is standard. Exactly. I was just checking. I was testing it. Okay. So to get it into factored format, which is what I call x-intercept format, We just need to factor that. Can you factor? Ooh, I think they left off an x there, didn't they? They had to. Yeah, that was definitely, I'm sure, a typo, because it wouldn't make any sense otherwise. Well, unless, no, well, actually it could be, but it wouldn't. They wouldn't write it like that. So let's see if we can factor that. My guess is we will be able to factor that. How do I factor that? What's the first step in factoring it? Split up the x squareds. I'm going to always start with the two closer factors. Always. And there's a reason. That's because most of the problems they give you in the state of Colorado, the answer is always the two closest factors. And this is purely a trial and error process. So we'll start with the two closest factors. What are both signs? Okay, plus and minus. Then we got factors of 9. Again, I'm going to try 3 and 3. Well, that's not going to work. That does not produce a middle term of 16x. Okay. What if I tried 9 and 1, which is another option? Does that produce a middle term? We're getting closer. What is the middle term if I use 9 and 1? Remember, you get the middle term. You get the middle term by doing the inside and the outside. The O and the I of FOIL. Oh, that's plus 2x. That's minus 18x. Combine them, minus 16x. So we did it right. In other words, that is the answer right there. 2x plus 1 times 2x minus 9. So y equals, that is the answer to the factored form. Okay? Now we'll do the vertex. Go ahead. Have to do 2x and 2x. I'll show you why. Nothing else is going to work. Here, let's try 4x. We'll try 4x, because I don't know that 2x is correct at first. It's just my first try. So, but usually when your first try works, nothing else is going to. It's still plus and minus. And you won't find any combination that produces that middle term. That won't do it. 9 and 1 won't do it. So there is almost always a unique solution. And since we found it using 2x and 2x, we're done. We don't go back and try 4x and x. Okay? This is kind of strange because I believe when we met in person, you did have one that had a 4x, and we did have to break it up as 4x and x, didn't we not? Yeah, we did. In other words, I tried it as 2x and 2x, and it didn't work. And so then I went to 4x and x, and we found a solution. And that is the way with these things, it's trial and error. You're going to try, in other words, there are two different factors for the number 4, and there's two different factors for the number 9. So that gives us 4 possible combinations we can try. Actually, more than 4. It gives us 8. And you just kind of have to try one until you find the solution. But once you find it, you don't need to go back and try others. Once you find the solution, that is it. Okay? So there's 1/3 way we need to write this first one, and that's in vertex format. Okay? So first of all, let's write vertex format. It's always a good starting spot when you don't know where to begin. And then let's write our function. So somehow we have to take this function and we have to put it in this format above. And the way you convert to vertex format always is by completing the square. So we're going to complete the square. What's the first step of completing the square? It's isolating all of the x terms with parentheses, leaving space to complete the square. Haven't changed anything, right? What's the next step of completing the square here? I couldn't quite hear what you said. Still couldn't hear it. My audio is not good on hearing what you say here. No, you have to get rid of that 4 that's in front of the x squared. So you have to factor it out. So I do it like this. Rather than trying to hear what you say, I'll just assume you said it. Notice I still have not changed it. It's exactly the same. And that's the key. Every time you go from line to line, make sure you did not change this original formula. In other words, if I take what I've got at the bottom and multiply it out, I get back to what I had, okay? Now, we got to complete the square. Inside the parentheses, how do I do that? Okay, what do you get? It's always being added because even if it's a negative number, when you square it, it turns positive. So what is it? What did you get when you divided negative 4 by 2 and then squared it? So when I write that 4 in there like that, how much did I just add to the right side of the equation? Not hearing you, Brianna. No? What is that 4 being multiplied by? 16. I added 16. The moment I wrote 4 in there, that 4 is being multiplied by 4, so I am adding 16 to the right side of the equation. So I got to subtract 16 to balance it. You with me? Okay. Now, that 4 that I factored out is still that, but everything that's inside the parentheses, I'm going to be able to write as a binomial linear term squared. What is it? It's going to be x what? X minus 2 squared. You'll notice that x minus 2 squared equals x squared minus 4x plus 4. It's whatever sign is in that middle term. It's half of 4. Whatever you got when you divided that coefficient by 2, that's what that number is. Okay? I hate it when they use 4 here because it's not clear. It'd be much better if they used 6 and then I would write 9 and you'd know what they were doing. When they use the number 4, you don't know if they're multiplying it by 2 or adding 2 to it. So I really hate when they use 4 here for these illustrations. Okay, now we have to combine those two numbers, which is minus 25. And bingo, we have it in Vertex Format. We have it in that format right there. What's A? What's H? No, H is positive 2. And what's K? Right. And now, if we wanted to graph it, well, I know where the vertex is. That's an awfully good start. The vertex is at 2, -25. The positive 4 means it opens up, so it's going to look something like that. So that's the value of the 3 different formats: the standard format, the X-Intercept format, and the Vertex format, is that you can graph it. In other words, my X-intercepts are these 2 points right there. And I have the X-intercept format. We wrote it down once, so I now know exactly how to graph it because I have the vertex and I have the X-intercepts. That's all you need. 3 points to find a quadratic. You don't need more than 3. You will get some teachers that they want you to plot 5, which is silly because you never need 5. It's like 2 points determine a straight line. Okay? If I have a point here and a point there, I got a straight line. I don't need 3 points. I don't need a 3rd point there. Same thing with a parabola. 3 points determine a parabola. You don't need 5 points. But there will be a lot of teachers that they want that y-intercept and then they want that point right there also. So your teacher might ask for 5 points. Okay, let's see. You'll notice that that's in what format? What format? No? Correct. Factored, which is also called X-Intercept format. Okay, and what format's that in? Okay, so we had, that one was in standard. That one we'll call factored format. And this one is vertex format. Notice that you can get, if I wanted to get that in standard format, I would just multiply them together. And then I would have it in standard format. If I wanted to get it into vertex format, I would multiply them together and then complete the square. That gets it in vertex format. You're always, almost always, completing the square in order to get it in vertex format. If I take C and I want to get it in standard format, just multiply it out. Whatever polynomial you end up with, that's standard format. And then to get it into vertex format, or to get it into the middle format, you just have to factor your quadratic that you get. Well, that's really a bad mistake they made there, leaving that X out there. And the reason it's a bad mistake is because I'm not positive it's a mistake. This is a quadratic, the way they have written it. It's just, I don't think that's what they intended. In other words, that quadratic would be 4x squared minus 25. Well, that's still a quadratic, still in standard format. Still, we can put it in vertex format, and we can also put it in factored format. So it's not necessarily a mistake. It's not necessarily a typo. It's just I gotta believe it is. It's just I don't see problems like that on tests ever. Now, okay. So, do we need to go through 13B and C, or should we go on? I've got, I've got like 3:40. I was late for starting. If you want to do a half an hour or a 1.5 hour session, I think we need to do like another 10 minutes. We don't have to do that. I'm perfectly content stopping whenever you want to stop, and I'll just charge you whatever time we did. I don't charge you an hour and a half if we only do an hour and 15 minutes. I charge you an hour and 15 minutes. So, okay. Okay. Yeah, no, I think that if you understand quadratics, the rest of these are going to be relatively easy. Once you get through 11, 12, and 13, this is actually kind of strange in that they put the hardest ones first. Usually teachers go the other way around. They give you the easiest ones first and then the hard ones. So 11, 12, and 13 would be at the end. But once you get through 11, 12, and 13, you've done all the hard ones. The rest is just math. There is one, let me just ask you quickly about. Let's just make sure you know how to get the vertex on this one. This is just a little trick that you may not realize until you do it. What format is it in? It's in factored format, right? What's the other word for factored format? X-Intercept format, meaning your X-intercepts are at 1 and minus 11. So, and we have a positive coefficient, so we know it's a parabola that opens up. What's the axis of symmetry or the line of symmetry? It's always halfway between those 2 points. So what is that? The equation of that line. And what's the x-coordinate of the vertex? In other words, when you have it in X-intercept format, you know what the x-coordinate of the vertex is. It's the halfway point, which in this case is minus 5. That's 6 units from the minus 11 and 6 units from the 1. Now, to find the y-coordinate of the vertex, you need to plug in minus 5 into the equation, and whatever y is equal to, you'll get the y-coordinate. But I wanted to point that out because when they give it to you in X-intercept format, the line of symmetry is halfway between those 2 x-intercepts. So you immediately have the x-coordinate of the vertex. And when you have the x-coordinate of the vertex, just plug it in and you'll get the y-coordinate also. Okay? Okay. Well, Brianna, if that works for you, I will let you go. And you and your mom can schedule online any other sessions that you want to schedule. Does this work okay on your phone? It really does. I mean, you see it large enough that you can follow what I'm writing? Because I wouldn't be able to write it on that small of a screen. In other words, if my drawing tablet was the size of your phone, I'd have problems. But on your end, it's not a problem apparently. And the sound is okay. The sound might be better if you used earbuds. In other words, if you have, oh, you are, okay, so am I. And that it does work a lot better. And it does eliminate a lot of the background noise, I think, when you use earbuds. So, all right. Well, Brianna, I will let you go. And good luck on your test. And I'll talk to you later. Bye-bye.